Last night's thunderstorm brought high winds, hail, and lots of lightning to the area. So in this week's Weatherwise, Chief Meteorologist Amy Metz lets us know why the lightning has been nearly nonstop in our recent thunderstorms. Hi, Amy.
Yeah, Brooke, we had a lot of people share videos and photos of this severe weather from yesterday that was lighting up almost every few seconds. Now, scientists and lawmakers are working together to understand more about space weather. So I sat with one of those recently who also has a meteorology background to chat about the connection between space and Earth weather. Let's hear from her.
I've got 150 SMEs, so SMEs, the subject matter experts, across the entire federal government. I want to say it's one of the biggest groups in the White House. We're all working together to understand exactly how far-ranging the space weather impacts are. A lot of what we see could cripple down into terrestrial weather. It's an emerging area of seeing just how intertangled our layers of atmosphere are.
Now, I actually got interested in space weather because as a meteorology student, I could not help but think our circuit board of the atmosphere, as I call it, that upper atmospheric layer a little bit above our weather-making areas, that is what I call the circuit board of the atmosphere, the ionosphere. So all of this lightning, come to find out as I was taking space weather courses, there had been one study out there to reference about how electron density does increase our lightning production. So as I watch solar flares leave the sun, I have sometimes noticed that actually every time I look, I notice there had just been a solar flare associated with the increased lightning. There'll be thunderstorms I'm watching, and all of a sudden there is just a ton of lightning, just nonstop. And every time I've noticed, it's a lot of electron input from the sun, from our solar flares. So what happens here, just so you can have an idea, we have electrons with opposite charges building up. This can be between any objects really, but most oftentimes we see cloud to ground lightning giving us a negative charge in the cloud with a positive charge on the ground. Eventually, these charges can come together. They'll rush toward each other with that positive one going toward the negative wherever these may lie. So we call these streamers, and electrical currents end up flowing from them and the stepped leader. So here we have the ignition of the strike once they connect and interact with one another. So this can repeat itself over and over again. That does tend to happen when we have these solar flares. So there's another study published May 13th in the Journal of Nature where we do see that this region near the ionosphere does trap the electromagnetic energy, and it did increase, doubling the electron density with an M-class flare.
Thanks so much, Amy, for breaking that down.